Hello, this is Rilirán Mortera Liñán. I'm a civil engineer student, and this is my ABET project, which is called Scouring Effects and Protection Against It for Pile Foundations. The objective of this presentation is firstly to understand scouring in pile foundations, present 3 articles related to scouring effects and protection against it, explain the methods used by the authors, identify the main findings, and discuss the relevance of the articles. So, offshore wind farms have become an important sector of clean and sustainable energy production. The solution usually given for this type of offshore structures is a pile foundation, okay? But piles are not only used in offshore wind turbines, they are also used in jack platforms or towed platforms, okay? And the foundation usually represents around the 16 to the 34% of the overall cost of the project. And pile foundations are negatively affected by scouring effects. So before I present you the articles, I would like to explain what is scouring, okay? Scouring is the result of the seabed erosion caused by the wave and current action. This commonly occurs when velocity is high enough to lift and carry the seabed sediments in suspension from the area. As you can see in the picture from your right, there we can see a scour hole, okay? This will obviously affect the behavior of the pile. So, first article is scour effects on pile-soil interaction in sand. Okay, this is presented by Wang et al. They present a new model of analysis to estimate the changes in the interaction between pile and soil once this phenomenon has affected the pile surrounding. Usually PY curves are used, but they are not very accurate. So Wang et al. Proposes this model, okay, considering soil resistance and stress, soil stress and strain, and pile displacement and soil strain. The main findings of their model, is the influence of the scour dimensional effect is bigger than the effect of the soil stress history by 138%. Also, as the scour depth and width increases, pile head displacement is greater and bending moment along the shaft as well does. And as the slope angle decreases, head displacement and pile moment increases. Second article is riprap protection in piles and effect on horizontal bearing capacity. This article is presented by Jing et al. And finite element method and the finite element method background propagation neural network response surface methodology is the method, okay, they use to carry out their model. And well, it is used as an example an 8 megawatt turbine located in the East China Sea, and the scour depth conditions are restricted to the API specifications, which can take a maximum value of 1.5 times the diameter of the pile. Riprap protection is a solution, okay, which consists of a structure built at the base of the pile that has contact, okay, with the seabed. And the main findings are that the test computed results demonstrate that as scour depth increases, the probability of failure also does, but reliability index decreases. Riprap protection considerably decreases the mudline rotational angle as the height of it increases. And riprap protection turns out to be a reliable alternative from reducing the probability of failure with confident reliability index results. Last article is also about a type of protection. In this case, is grouting protection against scouring. It was presented by Shang et al. And this experiment was conducted in a flom at the Ocean University of China. Pile A is protected with a cement sodium silicate grouting material, and pile B is left without any type of protection. They made this in order to compare, okay, how the pile would behave without protection and with grouting protection. For pile A, it was designed a high-pressure jet grouting system, and geometric, kinematic, and dynamic were considered on this experiment. The main findings were that the formation of scour holes was deeper in pile B, indicating that the grouting protection can significantly lower the scour depth. Positive effects are found in grouting protection due to an increasement of soil's density. Scouring protection does increase horizontal bearing capacity of piles, and grouting helps the surrounding sediments to stay in place. Consequently, more soil remains on its original place. Well, the conclusions around these three articles is firstly that the curves obtained from fundamental principles are necessary to address more reliable calculation and simulation of piles under scouring effects. This means that PY curves are a first approach, okay, to understanding the displacement of a pile. These graphs are usually done considering the type of soil, but they are not very accurate. So this type of new models, okay, provide a more realistic approach of the behavior of the pile. So I think it's very relevant, okay, to apply this for future projects. Also, scouring does have an impact on the bearing capacity and increases deflection. I mean, from the three articles that I analyzed, the three of them have solid evidence about the negative effects of scouring, okay? How they increase the displacement of the pile, they reduce their bearing horizontal capacity, and well, overall they do affect, okay, the piles. And both riprap and grouting protection are effective methods to considerably prevent scouring and increase piles resistance. And it is demonstrated that the effectiveness of protection against scouring, but specific modeling and work must be carried out in order to design in different locations. Also, I would add that in none of these articles it is compared different type of protection. So for future investigation, I think it will be very enriched to compare, okay, the different type of protections that are currently available, and also compare the economic feasibility of them. Well, that will be all of this video. These were the reference that I used to make this video, and I really hope you understand my point of view and what scouring does to piles and the protection against it. See you in the next one.